Welcome to online lectures by CA Studies. For more lectures online, please do visit castudies.lk.
Now let's look at our last section of the chapter, which is probability distribution. Probability distribution is linked to chapter 7, frequency distribution, where we show or saw how random variable data could be summarized with tables and charts such as histograms. So, converting the frequencies in a frequency distribution table into probabilities, we will create a graph called probability distribution. Now, probability distribution, let's take an example. Let's say for marks of a class of students, okay, marks of a particular subject. Let's say some people got 0, some got 1, 2 and 3. Yes. And then how many got is represented by the frequency of the marks. That means how many times we had 0 marks. That means how many students basically had got 0 marks. If 3 students got 0 marks, then we put 3 here. Okay. But for this, I'm going to put 0 students got 0 marks. 0 students got 1 mark. But 1 student got 2 marks. And 4 students got 3 marks. Therefore, you know that the frequency represents the number of times a particular mark is obtained. In this case, we have obtained once only 2 marks and 3 marks we have obtained 4 times. So, total number of times we obtained up from 0 to 3 marks is 5 times. Now, what is the total marks? That means total of all the students' marks. Frequency multiplied by the marks, which is basically Fx. I hope you all remember this from the 7th chapter. So Fx is 0 into 0. Right? Multiply. Get the answer. But sorry, this is the addition of 40. Okay. Now, once you have determined this table, what you're supposed to do is, once you have determined this table, what you're supposed to do is create the probability distribution data first. How to calculate probability distribution is, you apply this formula shown here, which is frequency divided by total frequency. Frequency is 0. That means this frequency. Divide by the total number of frequency, which is 5. Okay. Because 5 is the total marks of every student. No? So that is basically the total frequency. It represents the total frequency. So the frequency divided by the total number of frequencies is not number of, actually the total of frequencies is the probability distribution. In this case it is 0 and the other case, okay. In other cases it's 0 0.2, 0 0.8, and the surprising fact is that the total of probability distributions equal to 1. Somehow it must equal to 1. If your answer doesn't equal to 1, then something has gone wrong. Okay? This is very important. Why I said it equal to 1? If you go back here, the total of all the outcomes in a probability always will be equal to 1, no matter what. Okay? That's the rule of probability. So, this probability distribution also represents the probability. That means, what is the probability formula? Desired outcome divided by total outcomes. Total outcomes is 5. Out of 5, what is the probability that we will get 0 marks? Only 0 students got 0 marks. So 0 divided by 5. That is what we did. We applied this probability formula here. Okay. Same thing. Then here what is the probability of getting marks, 2 marks? Well, the total marks available is 5 out of 5 from the class, but out of 5, one student has got 5 marks. Sorry, 2 marks. So it will be 1 divided by 5, which is 0.2 probability. Right? Okay. Having obtained the probability distribution results, we have to draw the probability distribution diagram. Now your y-axis will be your probability distribution and your x-axis will be the frequency. So let me show you. So your y-axis will be the probability distribution. P, D, and your x-axis will be the frequency. Okay. So you basically have to probability distributions, if it is in a graph, right, it must be a histogram. Remember that. It is never any other graph. The format of the graph of a probability distribution is always a histogram. Make a note of it. Okay, format of the probability distribution graph is a histogram. Now, draw the histogram. How you draw is, at 0 frequency, the probability distribution is also 0. So, I am not going to put anything here. Okay. At again 0, 0. And then at 1, we have a probability distribution of 2. Then you draw a bar chart, like this. Okay, where it is starting from 1 and going until 2. Then we have the probability of having 4 marks is 0.8. So for 3 marks they haven't given anything. Straight away 4. So you go until 4, and 4 marks is basically, oh sorry, this is 0.2, okay, 0.2, so probability is 0.8 of having 4 marks. So what do you do actually? This should be like end from the number that we are looking for. Okay, so basically it should be in a histogram format. You will see it in this probability distribution graph, where you have marked the number of students here. That means the probability side here and the marks here as I showed. So basically this is what 2 doesn't represent anything. So 4 straight away it comes. Okay, so middle values we don't have here. So we can ignore, right? But the examiner will surely give with middle values. Okay, so the ending value is what you should look for. Then see these midpoints. If you mark the midpoints, see in this graph, they have marked the midpoints of each bar. Can you see that? If by doing so, what they are trying to show is, it is like a frequency distribution graph. Just go back to chapter 7 and refresh your knowledge on frequency distribution graph. You will see it looks like a curve, this type of a curve. And therefore, the area under the curve. So if you look at the diagram, if you look at this particular diagram, The area under the graph means, what do I mean by that? I mean this part. This entire section under the triangle shaped curve is equal to what? It equals to the frequency F, which is this total. Okay, it shows the number of students. And area under the, no, no, no. The area under the graph is reflecting, and okay, it's the frequency, the number of students of 5, as well as it represents also the probability distribution, which is should be area under the graph will always have a probability distribution of 1. So two conclusions we can form from a histogram of a probability distribution curve. Probability distribution, that is, our area under the graph, memorize this, area under the curve in a frequency distribution represents the, so area under the graph will be what? The probability distribution being equal to 1. So if they, in a probability distribution graph, if they ask what is the area under the graph, straight away without giving any information, they will just give the graph and ask what is the area under the graph. Then what you should say? You should say the area under the graph is 1. But if they give a frequency distribution table, a graph, frequency distribution graph, where the y-axis is frequency, not probability. If it is that, then the area under the graph will represent the number of students. So basically what I am trying to say is, whatever is in the y-axis only will represent under the area of the graph. Whatever in the y-axis. If you put the frequency distribution, then the frequency only will be the area under the graph. If you put the probability distribution, then probability distribution only will be the area under the graph, and the total area under the graph will definitely and always in every situation will be equal to 1. Alright? Remember that very well. Probability distributions of area under the graph will definitely be equal to 1. Okay? In a probability distribution graph, don't mix probability distribution and frequency distribution. Please don't mix those two. Those two are separate graphs. They might look the same format, but the y-axis is different. Y-axis stands for a different thing. Okay? The y-axis stands for probability distribution or frequency distribution. It can be two situations. In two situations, the area under the graph will be 2. Right? So that's why they say area under the curve in a frequency distribution is the number of students, but area under the curve in a probability distribution, which is what we just saw, probability distribution is 100% or 1. Okay? So remember that. So I might put distribution area, put a note, area under the curve. There can be two situations. Frequency distribution and probability distribution graph. In a frequency distribution, the area is always the total number of frequencies, which is F. Okay, the number of items, total number of items, not Fx, don't mix up, it is F. Okay, frequency stands for F, right? And but area under the graph for a probability distribution is always probability distribution or e of the value 1. Okay. So what is the value of area under the curve under a probability distribution setup? 1. But what is the area under the curve under a frequency distribution setup for this question? 5, because the total number of frequencies are 5 in this question, whereas probability distribution total is 1. Okay. Remember this, they might test in a MCQ. Also, area under the graph is the joining area made by joining the midpoints of the bars. Alright. So with that we finish the chapter probabilities, and you all can practice questions and we will discuss further. So you all can practice questions and we will see to questions as we go through the revision. Alright. See you all in the next video.
Thank you for watching the video. Stay tuned with castudies.lk for more lectures online.